All right, I just wanted to do one more hyperbola example before we move on to the next topic. So we have y of t equals 2 tangent t, x of t equals 6 secant t. This tells us opens horizontally. So when we draw our coordinate plane, we should go 1, 2, 3, 4, 5, 6. We have a point at 6, 0. 1, 2, 3, 4, 5, 6. We have a point at negative 6, 0. And then when we determine our slope, well, we don't have to do the full dy dt, but we know that when we do, or sorry, dy dx, dy dt has a coefficient of 2, dx dt has a coefficient of 6. So we're going to have a 2 over 6 coefficient in our fraction, which is going to say that our slope is going to approach plus or minus 1/3. Right? If we were to do the full dy dx, that's what we would figure out. And so when we draw our hyperbola, what we do is we go up 2 and down 2 to represent that coefficient of 2, just like we went over 6 and right 6 and left 6 to represent the coefficient of 6. And that makes our box. And really the sole purpose of making this box is that it allows us to sketch a line that has a slope with a rise of 2 and a run of 6, which is the same as a rise of 1 and a run of 3 as it reduces. So when we draw these diagonals, they're going to have a slope of plus and minus 1/3. So then now when we draw our hyperbola, it's approaching a slope of positive 1/3 and negative 1/3. There's our sketch. And here is the sketch in a better version right here. Desmos, okay? So you can see that our slope approaches plus or minus 1/3. The slope of this line is a rise of 1 over a run of 3. Okay, rise of 1 over a run of 3. Okay. All right, so stop and think. We have 4 different versions of the same curve, and I want you to convince yourself that all 4 of these red boxes represent the same curve. So we can start with this guy. If we multiply through by 100. Okay, well that's we're gonna have the 100 here cancels with this 100, and then we have 100 over 25. I don't know why I made that purple, sorry. And then 100 times 1. So we get x squared plus, what's 100 divided by 25? It's 4, and then 100 times 1 is 100. So these two are the same. Now coming down here, this is the same curve just with y isolated. So if we were to subtract x squared over, we'd get 4y squared equals 100 minus x squared. Okay, well then y squared equals 100 minus x squared divided by 4. Just divide that 4 over. And then if we square root, we get this. Y equals the square root of 100 minus x squared over 4. So now this is the same as this is the same as this. Now this version up here is what we would get if we converted this version to Cartesian form, right? This is just the parametric form of the curve. And so we can see this is an ellipse with a semi-major axis of 10 and a semi-minor axis of 5. So all 4 of these are the same. And we've worked with this kind already, and we're going to talk about these 3 kinds and how that relates to our lesson today. So we're going to talk about explicitly defined functions versus implicitly defined functions. So an explicit function is a function where the y and the x relationship is explicit. We can clearly see how y relates to x. Y equals this relationship with x, 100 minus x squared over 4 square rooted. Okay, so we know exactly how y depends on x. It's an explicit relationship. But if y and x are implicitly defined, it's really unclear how y and x are related. I don't know what y equals. I don't know what x equals. I just know that x squared plus 4y squared equals 100. So the relationship between y and x is implicit. It's harder to see how they are related compared to here where it's very explicit that y equals this. So this is what we call an implicitly defined function. X squared plus 4y squared equals 100. And we've always been able to take derivatives of functions that are y equals because we can just say dy dx equals, and we can just differentiate this side using our chain rule. In this case, that is kind of a difficult chain rule to do, but we could theoretically do that. We could find dy dx. But how do we do it if x and y are on the same side of the equation? How can we implicitly differentiate? So that's what this lesson is titled, Implicit Differentiation. So we're trying to take a derivative of this whole function with respect to x, which is our independent variable. So we are going to do d dx of this whole function, which is equivalent of just taking the derivative of x squared with respect to x, the derivative of 4y squared with respect to x, and the derivative of 100 with respect to x. So to understand what's going on here, I'm actually going to remove the x and the y for a second, and just think about what it means to take the derivative of something squared and the derivative of 4 times something squared. Okay, so we can apply our power rule to these brackets. So the derivative of blah squared is 2 times blah. The derivative of 4 blah squared is 8 times blah by the power rule. The derivative of 100, which is just a constant, is 0. So next what we have to do is we have to apply our chain rule, which says we now have to multiply by derivative of inside function. So we have to multiply by the derivative of whatever is inside in each of these cases. 2 times blah multiplied by the derivative of blah. 8 times blah multiplied by the derivative of blah, the inside function. So what is the derivative of x, the inside function, with respect to x? What is d dx of x? Well, it's just dx dx, which is just 1. Okay, so that will end up just canceling and not showing up. Now, what is the d dx of y, the derivative of y with respect to x? Well, that's what we're ultimately trying to figure out here. We want to know how does a small change in x affect a small change in y, right? What is our instantaneous slope? That's what this notation says. So we did 8 times blah. Now we have to multiply by the derivative of y, which is just dy dx. And now that is equal to 0 because the derivative of 100 is 0. So our ultimate goal is to solve for this dy dx because that's what we could do with an explicitly defined function. We could say dy dx equals blah. So now we want to isolate dy dx. So we're just going to treat it like it's any old variable and just get it by itself by undoing the other operations. Okay, so we subtract our 2x over. 8y times dy dx equals negative 2x. We divide our 8y over. Divide 8y on both sides. And then that simplifies to negative x over 4y. This is our derivative. Dy dx equals negative x over 4y. I'm going to do those steps one more time, step by step here. So we're going to take d dx of x squared plus 4y squared equals 100. d dx of x squared is 2x times dx dx, which just cancels to 1. The derivative of 4y squared is 8y squared times the derivative of y with respect to x by the chain rule, and that's equal to 100. Now, 8y squared times dy dx, or sorry, not 8y squared, just 8y. 8y times dy dx equals negative 2x. Okay, dy dx equals negative 2x over 4y, or 8y, which equals negative x over 4y. That's our final derivative. So the questions that this can help us answer are what x values produce a horizontal tangent line? At which points is there a horizontal tangent line? So not just x, but what's the x and the y? And then at which y values is there a vertical tangent? And then what points are there a vertical tangent? So think about this expression and what is going to make a horizontal tangent versus, oh, excuse me. Wow, sneezing over here. Okay, so what is going to make a horizontal tangent? What's going to make a vertical tangent? Well, horizontal, okay, slope is 0. Vertical slope is undefined. So what's going to make this slope equal to 0? What x value is going to make the whole slope equal to 0? Okay, well that's going to be x equals 0, because you have 0 divided by something is 0. What is going to make this undefined is if the denominator is 0, and that would be when y is 0, because that's going to make us divide by 0. So when x equals 10, well, we know from the original function when x is 10, y is 0, because we get 100 over 100 plus 0 equals 1. So when x is 10 and y is 0, our slope is going to be vertical, because we're going to get negative x over 4 times y, which is undefined. And because this is an ellipse, we can see that where that vertical tangent happens. Okay. What about when x is 0? Well, then y is going to have to be 5, because 5 squared over 25 equals 1. X is 0, y is 5. We get x over 4 times y, which is 0, and we have a flat slope at 0, 5. And then it's going to be something similar at negative 10, 0, and 0, negative 5. Okay, horizontal, horizontal, vertical, vertical. Again, if we plug these x and y values into our dy dx, we should get an undefined slope and a slope of 0. Quick connection to the parametric. This is the parametric form. X is 10 cosine, y is 5 sine. So dy dx then should be, we can just substitute. What's x? X is 10 cosine. Y is 5 sine, so we're going to do 4 times 5 sine. Okay, that's going to simplify to negative 10 cosine over 20 sine, which then simplifies to negative cosine over 2 sine. And I think that if you found, oh yeah, if we look at dx dt dy dt now, so what do we get? Negative cosine over 2 sine? Okay, well, how do we find dy dx from here? We just divide them. So we get dy dx equals 5 cosine over negative 10 sine, which simplifies to cosine over negative cosine over 2 sine. Okay, which is what we got over here as well when we just replaced our x and our y with the original x and y. So clearly the slopes are the same whether we're in parametric or Cartesian form. It's just in parametric form we have it in terms of t, and in Cartesian form it's in terms of the x and the y. So similar to before, if we just multiply through by 100, that's going to produce y squared minus 4x squared equals 100. So now we're going to implicitly differentiate this. You can pause this and try to do it by yourself. Okay, and here's the answer. So if we take d dx of this whole thing, what's the derivative of y squared? It's 2y times the derivative of y with respect to x, minus, what's the derivative of 4x squared? It's 8x times the derivative of x with respect to x, which is just 1, so we don't have to write that. It's equal to 0. So then we get 2y dy dx equals 8x, and then dy dx equals 8x over 2y, which equals 4x over y. So that is our final slope of this hyperbola. So there would be a vertical tangent when y equals 0, because that would produce 4x divided by 0, which is undefined. But that's never going to happen, because if we think about how to sketch this hyperbola, well, we're going to have a point at y equals 10, x equals 0, and y equals negative 10, x equals 0. And it's going to open vertically because the y value comes first. So it opens vertically. Okay, so where is the y value equal to 0? The y value is never equal to 0, so we can never actually plug in 0 to dy dx. So what actually ends up happening is that our derivative, 4x over y, falls between negative 2 and positive 2, because this slope is going to approach plus or minus 2. So this can never be smaller than negative 2 or bigger than 2, which means it can never be vertical, because a vertical slope is an infinite slope. So we're never going to hit an infinite slope because we fall between these two, because it opens vertically. Okay? But we will have a horizontal slope when x equals 0, because that point exists, right? X equals 0, x equals 0. Okay, we have that horizontal tangent there. And that's when we have 4 times 0 over y, which is just equal to 0. Okay, last two, you can try these by yourself, and then I'm going to skip to the answer slide, so pause.